Join the STATE16 Community webinar, live on Zoom, July 22 at 20x Israel
over
time.
10 years from a lot of experience, and what he did in HuggingFace is amazing. This is a really huge contribution to the world, and Stephen joined us today from Paris, and thanks again for taking this invitation and join us, and you will do a great job with a VLA, world model, data collection, policy training. I mean, all of the nice buzzwords those days, and you have a huge and rich experience of working with robots those days. And I'm really glad to have you with us, and wish us amazing, successful, mutual work and road to this world of the physical AI. And Steven, the stage is yours.
Yeah. Awesome. Can you guys hear me? Yeah.
Yeah.
Okay. Awesome. Well, thanks a lot, Barak and STATE16, and thanks everyone as well for being here. Very interesting talks. So shout out to the previous speakers. I think even in these 90 minutes, Barak, we all managed to learn a lot. So I'm very happy to be here. I'm just gonna I think currently you're looking at the entire keynote space, but if I do this, do you guys see the entire presentation?
Exactly. Yeah? Yes.
Okay, awesome. That's great. Let me just minimize over here. Okay, so I'm gonna try to be fast because we're tight on time. Also to respect everyone's being here. As Barak said, I'm Steven. I do robotics at HuggingFace, and I guess it is also, although we're gonna talk mostly about robotics, it is also to a certain extent fair to talk as well of what we do in general in HuggingFace. So HuggingFace essentially is this platform that helps AI builders, engineers, scientists build AI in general. And I know I'm a little bit blurry in that sense, but HuggingFace, it allows you to, or it gives you access to all the infrastructure that you need to develop such tools and solutions nowadays. Namely, it helps you with the models, the data sets, the application, everything in the same platform, everything in the same infrastructure, so you can focus on your own AI application, right? And how that looks like is most of the times, people come to HuggingFace Hub and HuggingFace in general to deal with, as I said, data sets, which I like to think about kind of like the ingredients, right, of all these AI happening nowadays. Then the models, which is kind of like the recipe cooking, right? And then the spaces, which is kind of like the restaurant experience, so to say, right? But this is essentially, HuggingFace gives you all the tools, all the infrastructure to share, collaborate, version, data sets, models, and applications, right? So this is HuggingFace. However, we're here to talk about, as Barak correctly introduced at the beginning, the robot, which is one of our robotics initiatives here at HuggingFace. And it just stemmed from the fact of, we ask ourselves, how can we bring all these AI breakthroughs, right, and all these AI innovations, mostly coming from the LLM space, into robotics and to make physical, right? To what we now consider physical AI. So this is how the robot was born, right? The robot is essentially about making robotics more accessible to everyone, right, in the community, mostly by end-to-end learning. And we're going to learn a little bit more about that in the following slides. As well, feel free to, I don't have access to the chat, but I will check it after the presentation. So the robot, it is essentially a software library. Well, it is open source, that walks you through all the different steps, all the pipeline that you need in order to play and experiment, deploy, even build your own solutions on top of physical AI, mostly imitation learning, but not only, right? We also have reinforcement learning and so on. And these different steps, as we can see here in the little diagram, is they are very sequential and logical, right? The first one is we're gonna need a robot. We're gonna need hardware, right? So the robot takes care of that. The robot as software library takes care of that. Then the second step is, well, you eventually need to move the robot, right? Just teleoperate it, make it automate a task, right? So for that, you need the glue, which is kind of like the software that will control the hardware, right? In order to make the robot move. Then the third step is, well, once you have your robot and you're able to move your robot, then you're interested in recording data sets, right? Recording examples, imitations, well, not imitations, demonstrations of the task that you want to automate, right? This is gonna be kind of like the source resource for the model, which is actually the next step, right? Which is, okay, now I have my data, I have my robot, I can move it. Now I want to train a model, right? Which model can I choose, how, and so on. This is the fourth step. And then from here, the fifth and the sixth is essentially, okay, once I train my model, what can I do with it? I can deploy it on the robot, see it move, see it automating the tasks that I train it for, or I can also improve it or evaluate it with different benchmarks, right? But overall, the robot, right, it is this it is this software library that allows you to experiment with all these different steps in the pipeline, right? So we're just gonna go deeper into each one of these. So first, the robot, right? And the idea, or the reason why this is important, the reason why this is important is because if someone who wants to experiment with physical AI needs $100,000 robot, then no one is gonna do it, right? The importance of having robots who are easy to use and accessible is precisely that it allows everyone to experiment with the project, and most importantly with the tools and with the innovations that are happening in the space. So HuggingFace here, we were the ones who pushed the SO100 arm. We also have some other platforms like the Kiwi and so on, which are essentially just vehicles for people to experiment with the rest of the project. Awesome. Then, okay, you have your hardware, as I said before, but you're also interested in like making sure that you can move it. And the robot in the project, it gives you also that control, right? Not to all the robots, just to some, but enough for you to like start moving the robot, right? Start controlling it via a VR headset, via the keyboard, via another teleoperator device, right? The idea here being that from the moment that you decide to give it a try to the moment that you see something moving, it takes you really 10 minutes, right? That's kind of like the idea. Awesome. And then we have the datasets, which is arguably one of the most important parts of the project, because what happened is you will have different research labs experimenting with physical AI, doing their own thing. And then when they were coming out with the results, it was very hard to replicate because they were just using different, data set format. They were using their own environment and so on, right? So the robot, one of the reasons why it has become so popular is because to a certain extent, standardize how we share, contribute, version physical AI data, such that everyone can leverage on someone else's experiment, right? By that, I mean, let's say that you went and you recorded some data for training your models in the supermarket, right? Of a robot just picking up pickles or whatever it is. Then as long as it is in the HuggingFace hub, everyone can leverage this data for their training. And then that means that we are kind of like speaking the same language, right? When it comes to data. And it turns out to be very popular, right? I mean, nowadays the graph is a little bit outdated, but the last time that I checked, we have over 150 terabytes worth of the robot dataset format in the HuggingFace app. Awesome. And then we move to arguably, the intelligence part of the project, which is essentially the policy architectures. This is essentially the part in which the physical AI world kind of adopted all the innovations and the breakthroughs from the LLM space, right? And we're trying to, apply ChatGPT-like technology into the robots, right? So in here we have, I guess this is just a couple of examples of what is available in the robot. So we have talked about the hardware, we have talked about how you can move it, we have talked about the data and how to collect it. So this is essentially the architecture of the model that you're going to train based on the data that you collected, right? So we have very simple things or kind of like pioneers like ACT, but we also have slightly more advanced, which were other topics to touch on in the previous talks, like VLAs, right? Vision Language Action Models. And here we're seeing the architecture of Isaac Root, but actually 1.5, but actually we also have 1.7 implemented into the code base. And with this, what I'm just trying to convey here is that the robot is kind of like this one-stop shop for robotics learning in general, because you can just go and experiment with different models, maybe with the same data set, maybe with someone else's data set, and then just iterate in your development loop. And most importantly, just get a grasp, get an intuition about how these physical AI demons and robots actually work, such that you can contribute back into the field. Right? I think we have all seen in social media, crazy videos of a robot doing a backflip and so on. So the idea of the robot being open source is kind of like to democratize the knowledge on how that kind of works and make it community first. In here, we're also, this is kind of like the part in which I also explained that we don't only have VLAs and basic transformers architecture policies, but we also have some other model types like word models recently integrated in the latest release. But we also have reward models, right, which kind of gives you an intuition of how your task is progressing over time, and then you can use that to either filter your training data set or maybe just evaluate your rollouts and so on, right? And this is also the part where I want to highlight STATE16, because this is essentially where we're also interested in like making sure that we have, or we put available a guardrail of safety when the robot is actually executing these policies, such that people can iterate on that and build, as I said before, build an intuition about, okay, this is the limitation of the model. This is what the safety guardrails are helping me with. Okay, awesome. And then now going to the last two steps that I explained in the beginning, we also have all the inference tools that you will need in order to play around with the model that you train in the robot, again, as a software framework, right? And here, this is just simple examples of, the SO100 running a model, but we also have things like the Unitree G1 here running a policy, and then you just see if the robot actually automates the task that you want it to, and then you can evaluate how diverse could the environment be while still accomplishing the task. Will give you an intuition of how general your model is in broadly speaking, right? Not only that, we also have some benchmarks, mostly academic. We have over, I think there are at this point 8 or 9 benchmarks, which essentially helps you answering the question, hey, I trained my model, I did some changes in my architecture, maybe I did also some changes in my data set, whatever. How good is it compared to my previous model, right? So these benchmarks, they do a bunch of rollouts, and at the end of the day, they give you a success rate, right? And that you use that success rate percentage. Let's say one of the most famous ones is Libero, right? My model got 80% Libero, but I did this slight change in the architecture, and now I got to 90% on Libero. So then that means that my model took a step towards being more general, or what we refer as general in the model. And then we have plenty of different benchmarks, all available in the robot, unified under the same CLI and API, such that everyone in the community can, as I said before, speak the same language. Talking about community, this is also what makes the robot so special, which is we really try to stay connected with the community, go to these events, learning about what people are doing in the field, because the whole idea of the project is to be accessible, right? And if the technology is gate kept by research labs or private companies, then no one is actually benefiting from that. we benefit from an ecosystem that is open, and we all share our learnings, such that, for example, if I do a breakthrough in the dataset part, then someone else can, or that will unblock a breakthrough in the policy architecture, and then maybe that will unblock a breakthrough in the benchmark space, right? So this is kind of like the reason why here in the robot we take the community so to heart, because it allows an open ecosystem and a more faster and innovative field. This is actually the map of a worldwide hackathon that we did last year. I think I don't remember specifically the amount of cities that were participating, but you can see here the map that there were plenty of people willing to spend their weekend building a robot and just sharing with the world what they built with the robot and the software. Okay, awesome. And then some other thoughts. So far, I have been talking a lot about accessibility and low-cost hardware and so on. But then that doesn't mean that the software cannot do also some complicated tasks, right? As long as you get slightly better hardware, slightly better data collection, and slightly better compute capabilities, then you can do, way more kind of like useful tasks. In here, we have a t-shirt folding experiment that we did before, and we open source all our learnings, models, data sets, and so on, right? This only to give an idea of what are the capabilities of the project itself, right? And what it allows the community to do with all the different steps that I explained at the beginning. Same in here, right? We have more things coming, different, the field is changing fast. So we also try to integrate all these latest state-of-the-art things coming into the field such that everyone can experiment and even build solutions on top. Talking about building solutions on top, there have been startups, companies, even unicorns nowadays that were born and they build their solutions on top of the robot. And what I like about this slide is that it is not only private companies or startups, but you also have, big corporations and also academic labs, right? Like research labs. So we have all these three ecosystems coming together because we all benefit from having a common physical AI framework to work with. Awesome. So after this, maybe you're thinking, well, that might be too complicated to give it a try. Well, if it is too complicated, then probably I didn't do my job correctly because it is something that we try to make sure that it is easy to use, right? So I encourage you to give it a try. Just a pip install the robot and then you're ready to go. Just the last word in here, we recently released our newest version, 0.6, which is all about word models, reword models, benchmarks, and a lot of improvements on the dataset part of the project. So feel free to give it a try. And as well, feel free to engage with the community and send us a message whenever you're exploring something new. This is just a small sneak peek of, hey, we are always, trying new things as well here internally. This is a biped open source platform that we published not so long ago. And this is just, to give you an idea of the exploration paths and how open the project is in general. So without further ado, thanks everyone for being here. And then I'm going to leave you here some 3 links. I think as Barak has insisted in this call today, this is actually the most important slide of the presentation. Don't get me wrong, right? Because this is the part where you actually engage with the project and the community. So feel free to give it a try. We have the GitHub in order for you to dive deeper. We have the Twitter account in which we kind of like publish our news in general, and then we have the Discord server in which people come together, they ask questions, they'll help each other, and this is how we build a vibrant community around physical AI. So thank you again.
Steven, thank you so much. I really appreciate that you joined us today, and I believe that what you're doing together, yes, with the STATE16 Physical AI Community can lead to really a better physical AI world, because eventually you push the world with a lot of data sets.